Velociraptors, and welcome to the Texas state capitol. We're here today for two primary reasons. First, the place I wanted to take you was too far out of the way. Two, is because of the beautiful pink granite that makes up this iconic building in downtown Austin. Where did it come from? It might surprise you, but this granite is from here in Texas. It's a remnant from some of the major tectonic activity in Texas's past. Currently, Texas resides on a passive continental margin, meaning that there's no major tectonic activity. However, major tectonic activity in Texas's past is what has created the landscapes we know and love. To understand this, we need to watch Texas, or we need to take a trip back in time and watch Texas through the ages.
As we look at Texas's geology, we notice that it's a very diverse and complex system. There's a lot of variations in color, and these different variations in color are indicating different explanations present here in Texas. And an explanation is just a layer of sediment. And we'll get more into some of these examples as we move forward. Now, as I was saying earlier, Texas is currently present on a passive continental margin, meaning that as we notice here, this is showing you the tectonic plates of the world, and we can see all of these active plate boundaries, and Texas is not currently on one of those active plate boundaries. But that's okay, because we already know, and we're going to get to more detail of it, that as we move through Texas's past, those tectonic boundaries actually cross Texas. Now, before we get started in our trip back through time, I want to point out where we're going. For this video, we're going to be moving through the Precambrian and then focusing on the major eras, Paleozoic, Mesozoic, and Cenozoic. In terms of this course, remember, my more concern is that you know the eras. In terms of periods and epochs, not necessarily important. We're going to definitely indicate some priority periods, such as the Quaternary, our current period, Cretaceous, Jurassic, Triassic, we'll hit a little bit, Permian, Devonian, Ordovician, and Cambrian. A lot of those you're going to use throughout the course when we explain certain content, and you'll associate that with that as we move forward. But of course, not necessarily to memorize that in terms of the geologic timescale. So let's go ahead and get started, and we're going to take a little trip back in time to the Paleozoic era. And I want you to indicate the Paleozoic era is from 545 to 245 million years ago. And when we look at Paleozoic, the globe in today's or Paleozoic Earth, it looks something like this. And if you look at Paleozoic Earth, it's referencing that large landmass. So at the beginning of the Paleozoic, we have all that landmass kind of crushing together, creating that large supercontinent that you're probably aware of, previous Pangea. And that's currently where we are. And if you think about where Texas is somewhere kind of right here, landlocked in the center of that Pangea. And now the question is what does Texas look like during this time? And we have a little artist rendition here for you to kind of showcase what Texas might have looked like. And I want to point out a few key features. One, you can notice that all of the animal life, or the diverse life, is located in the sea. We haven't yet progressed to land or air life. It's mainly focused here in the sea. The second thing I want you to notice is it's covered by this shallow sea present, and that's because of that waterway that was running through here, Pangea. So in terms of geologic processes, we know that it's deposition dominant. So in your geologic time review, we know that in terms of Earth's history, it's always been undergoing these two geologic processes, deposition and erosion. In this instance, deposition is dominant, so we're depositing a lot of layers during this time. I also want to point out these large mountains in the back here, and those are left over from the Precambrian era. So there wasn't much going on in the Precambrian area, and we'll get back to that later with the Cambrian explosion. But I also want you to notice that there were at one time these large mountains present here in Texas, probably roughly around the size of the Himalayas, as estimated. But currently, right now, any mountain building occurring is that crushing or pushing or uplifting of the land as we're colliding with Pangea. And a lot of this we can see today in current Texas, first as the Guadalupe Mountains. And the Guadalupe Mountains are actually an uplifted reef system from this time. So you can actually see, or this cliff face that you're looking at, that's actually a coral reef from the Paleozoic era. So an example of, you can see, if you check them out, definitely do. I haven't got a chance yet, but definitely on the list to check out. The other thing that you might notice or see at current time is if you go to Palo Duro Canyon, you're going to see a lot of this colorful minerals. The dirt has this nice rich color. All of that is from the deposition that was occurring during the Paleozoic era. So again, remember the information that I'm providing you is based on geologic evidence that we have today, or current today, that have been tested. Now that kind of takes care of the Paleozoic era. So we have deposition dominant, Pangea occurring. A lot of Texas's history happens in our next era, the Mesozoic era. So I want you to indicate the Mesozoic era is from 245 to 65 million years ago. Now, in terms of where we are on the time scale, we can see we've moved Precambrian, not much going on here. Those mountains was about it. Cambrian, we'll talk about Cambrian explosion later. Paleozoic, deposition dominant, shallow sea. And then we go to the Mesozoic. And during the Mesozoic time, something dramatic happens in terms of Texas. And I want to point that out by looking at what the globe looks like. So I'm going to start here early Triassic. So I'm going to show you one more time this geologic time. Mesozoic goes Triassic, Jurassic, Cretaceous. And we're going to look at the globe at each instance of those times. So if we look here, Triassic. Triassic, again, remember, Texas is right down here in the kind of center of this Pangea. And we have what is known as a fold thrust belt. And a fold thrust belt just means at the same time the continent is folding inward and thrusting upward. Because they're normally paired together when that's basically, you can think of it as there's a lot of tectonic activity occurring here. Mountain building that we might see here on this fold thrust belt. Now I want you to notice, okay, so if we think about this as North America, right now this fold thrust belt is right here, which would be present day the east coast of North America, or the United States. And if we look at the Jurassic, again, we were in Pangea begins to break up much more. I don't have the fold thrust belt featured here, but I want you to notice what happens when we shift to the Cretaceous. Now we notice that fold thrust belt has moved from eastern, which is kind of underwater right now, to the western side of the United States. So again, here, let's look at early Triassic. Fold thrust belt is on the eastern coast, and now it's shifted to the western coast. Now, I want you to take a second and think, what do we know that's on the east and western coast of the United States that might have been produced by an enormous amount of tectonic activity? Well, hopefully you've reached it. That would be our Rocky and Appalachian Mountains. So if we see here, we have the Appalachian Mountains, which were created first when we were kind of embedded in the middle of Pangea. And then as we shifted through the Mesozoic era, that fold thrust belt has shifted all the way to the west coast, where it's building the Rocky Mountains. And these are key points for what happens in terms of Texas. So one, that fold thrust belt has shifted right through Texas in terms of Texas's past. Also, it helps to create that shallow sea that most of you are familiar with in terms of Texas's past. Because during the Mesozoic era, we have a lot of this glacial melting happening up here. As that glacial melting occurs, it flows down to lower lying land. And these mountains help to funnel all that water from that glacial melting right over Texas, which helps to maintain the shallow sea over Texas. It's also what causes all of that deposition and creates all the limestone that we see in Texas today. So if we think about an artist's rendition of this process, Texas looks something like this now. So this is Mesozoic Texas, again, 245 to 65 million years ago. Animal life has thrived past the oceans. It's now on land, in the air. There would have been a huge amount of dinosaur diversity at this time. Active volcanism occurring because we have that fold thrust belt. It's shifting from the east to the west coast. Also, there's active volcanoes kind of present as volcanic islands, kind of posted a little bit around here in central United States, southern central United States. Of course, a few theories based on those. But again, we also have deposition dominant. So at this time, sediment is being produced very quickly, and it's creating all this limestone that we see today in central Texas. It also helps to produce a lot of the fossils that we have in the fossil record. So if you travel over to Blanco River or Dinosaur Valley, you'll see dinosaur footprints. And these dinosaur footprints are from this Mesozoic era. So Glen Rose Formation, that's just referencing the explanation. So that's the limestone. So Glen Rose Formation just means limestone. This K just means Cretaceous. So this is all of the limestone from the Cretaceous period. And as these dinosaurs walked through that mucky, shallow sea, they left behind footprints that were able to be encased as fossils. Now, how did that happen? What we mean is that their footprints left a deep impression into that mucky sea floor. And what that does is that compacts that part where their foot pressed down into the mucky water. Now, while they're gone and away, that compressed region becomes covered by more and more sediment. And now that sediment that's on top is much looser than the sediment that was compressed due to the dinosaur stepping there. Thus, later when erosion occurs, it's only going to erode away that top layer of less compressed sediment before the bottom layer. And then that leaves that perfect footprint there that we see in the creek bed. Created by this one is actually this dinosaur. And it helps us to see the diversity of life and see what's occurring in terms of that time period in terms of life. And now, of course, as we transition from this time, we reach the Cenozoic era.
The Cenozoic era marks the end of the dinosaurs, which we'll discuss later in the mass extinction module. Welcome to the current period, the Quaternary period. During this time, that shallow sea from the Mesozoic era has now receded, and it's caused a differential loading of sediments, which we'll discuss later in the next video. In addition, the dominant geologic process has now changed from deposition to erosion, and you can see that behind me in these limestone slabs that were deposited during that Mesozoic era. This period of erosion has led to the unique geologic features we see here in Texas, and especially here in Austin.